Okay, dear students, in this video we are going to discuss that when orthocenter of a triangle formed by the homogeneous equation, then how to find the third side. See, look at this one. This is the one shortcut formula. This is the very most important in objective point of view. See, look at this one. If the equation ax square, if the equation ax square plus 2hxy plus by square is equals to 0 represents two sides of the triangle whose orthocenter is alpha comma beta, then equation of third side is alpha plus a plus b into alpha into x plus beta into y is equals to here this one is the b into alpha square minus 2h into alpha into beta plus a into beta square. This one is the equation of third side. So please all of you remember this one. Here once again you see this one, a plus b into alpha into x plus beta into y is equals to b into alpha square minus 2h into alpha beta plus a into beta square. This one is the third side. That means here all of you see this diagram to understand that given statement. This is that xy plane. Now the homogeneous equation will represent the two lines passing through the origin. Now let it be these lines are that OA and OB. Now by joining these 2 points, this one is the third side. So how can we find the third side? When orthocenter, here you denoted by H. Orthocenter is denoted by H. So when H is that given as that, h is that given as that alpha comma beta, then the third side will be a plus b into alpha into x plus beta into y is equals to b into alpha square minus 2h into alpha beta plus a into beta square. Now we will see that one example based on this formula. Okay, see that one example to the above formula, that is when orthocenter of triangle is given and two of its sides are given, then how to find the third side. By using this formula, here this one is the represent that alpha comma beta. Here what is that given equation? Given that this equation will be given that 3x square minus x into y minus 2 into y square is equals to 0, right? Now here a is equals to 3 and b is equals to minus 2. What is that formula to find the third side? Therefore equation of third side is now you see that above formula a plus b is that 3 minus 2 into alpha into x plus beta into y. So alpha is that 4 into x plus beta into y is that 1 into y is equals to b into alpha square. That means here you interchange this one, you substitute that b is that minus 2 into alpha square is that 4 whole square, that is that 16 minus 2h into alpha beta. Here is that plus, here is the minus x into y. That means it becomes that plus alpha into beta is that 4, and next one is that plus a into, that is that 3 into beta square is equals to 1 whole square is that 1. Now simplify this equation. Now you will be get this value is that minus 16 into 2 is that minus 32 plus 4 plus 3 is that 7. Okay, so that implies minus 32 plus 7 is that how much this value? Minus 25. Minus 25, if it get that left hand side, the equation will becomes that 4 into x plus y plus 25 is equals to 0. So your answer will be that what? Fourth option is the correct answer. So your answer is that equation of the third side is that 4x plus y plus 25 is equals to 0. Fourth option is that correct answer. Okay. Now the next model is when three sides of the triangle are given, then how to find the orthocenter. How to find the orthocenter. We will see that model. Okay. See, in this problem you have to find the orthocenter of triangle formed by this pair of equation and this line. So here is that what is the given equation? Given that first homogeneous equation is 6 into x square minus x into y. Here is that minus y square is equals to 0. This is the one equation. Let it be, you see, this is the one equation. And next one is that x plus 2 into y minus 5 is equals to 0. Minus 5 is equals to 0. See, please all of you understand the concept of the orthocenter. Suppose if these lines will be form a right angle triangle, then orthocenter in a right angle triangle will be the right angled vertex. Now see this figure. Here is that homogeneous equation will be represent that lines passing through the origin. Now how can we verify that these lines are perpendicular or non-perpendicular? Now in the given homogeneous equation, if sum of x square and y square coefficient is 0, these two are the perpendicular, okay, at the origin. So clearly in this equation, these two are, sum of x square and y square coefficient not equals to 0. Now let it be this one as that A and this one as that B. Now the third side will be this equation. Third side is that this equation. Now all of you see this one. Orthocenter. Orthocenter is that point of intersection of altitudes. So that means here that one altitude is that passing through the origin, and another altitude is passing through that vertex A, and another one is that vertex B. Now you see this one. Here this one is perpendicular to AB. You know AB equation is that what? AB equation will be, here is that x plus 2y minus 5. X plus 2y minus 5. Here you take that, let it be H is the orthocenter of the triangle. Now you take one by one all the options as that H. First you take that 2, 1 as that H. Now here you see this one. From the first option, option 1, option verification. From the first option, slope of OH is equals to, that is equals to, this one is that H is the 2, 1, O is means origin, that is equals to 1 by 2. Now here is that the slope of AB is that minus 1 by 2. The product is not equals to minus 1 because of here altitude is perpendicular to that AB. Here is that altitude passing through that O is perpendicular to AB. Next you take that option 2. From option 2, H is that 1, 2. That means slope of OH is equals to, this one is that 2. Slope of AB is equals to minus 1 by 2, and slope of OH is equals to, from option 2 is that 2. Clearly product is equals to minus 1. That means orthocenter will be 1, 2. Okay, this one is the satisfying that orthocenter condition. Okay, here if H is the orthocenter, that condition is that OH is that perpendicular to AB. OH is perpendicular to AB. First this is the fundamental rule. Now next you check that option 3. What is that slope of OH? Slope of OH is equals to, this one is that 3 by 2. Right? Slope of AB is equals to minus 1 by 2. So the product is also not equals to minus 1. Option 4. So what is that slope of altitude OH? This one will be equals to 2 by 3. So here also the product is not equals to minus 1. So which option is satisfying the condition OH is perpendicular to AB? Only the second option. So here is that clearly slope of altitude OH into slope of AB is equals to minus 1. Okay, So from the second option. So your answer will be that option 2 is the correct answer. This is the very best method to find orthocenter of the triangle, right? When if the given triangle is not form a right angle at the origin, okay, right? This is the simple method. Now we will see that one more problem in the different expression. See that, okay? See, in this problem you have to find the orthocenter of the triangle formed by the second degree homogeneous and this linear equation. We know that first of all you draw the figure. The homogeneous will be represent the two sides which passes through the origin. This is that one side and this is that another side. Let it be, this one is that A, OA and OB. Now the linear equation is that third side will be this one. So here is that you see that 3x plus 4y minus 5 is equals to 0. This is the third side. And OA and OB are represented by given homogeneous equation. What is that given equation? 6 into x square minus x into y minus 6 into y square is equals to 0. Right? So and AB is equals to 3x plus 4y minus 5. This is that AB. Now in that homogeneous equation, clearly A plus B is equals to say 6 minus 6, that is equals to 0. Now if A plus B is equals to 0 means now these two lines are perpendicular. What is that right angled vertex in this one? So here origin is the right angled vertex. So therefore triangle angle AOB is equals to, this one is that pi by 2. So in a right angle triangle, orthocenter is the right angled vertex. Which is that orthocenter? Which is the right angled vertex? Origin. So origin is that orthocenter of the triangle. Suppose how to find if the right angle vertex is either A or B, that also you can do it. Okay, that we will discuss that later. Now you see the next question in the same model, but same model means a little bit of difference is there. Now in that above problem, the given second degree equation is a homogeneous, but in the next question the given second degree equation is the non-homogeneous. See what is this one? Here is that given equation is x into y plus 3 into x plus 3 into y plus 9 is equals to 0. Right? So you know that what is the standard form of the non-homogeneous equation? Ax square plus 2hxy plus by square plus 2gx plus 2fy plus c. Now in this equation there is no x square and y square term. That means you can write 0 into x square plus 0 into y square. That means coefficient of x square plus coefficient of y square is 0. That means this non-homogeneous equation, in any second degree non-homogeneous, if x square and y square terms are not given, that equation will represent always the perpendicular lines. Right? So what is that point of intersection of the perpendicular lines? That means so the diagram will be, say here that given equation will be represent these two. The given equation will be represent these two. How to find these equations? See, let this one you take as that S. let this one is that yes, directly if you can do the factors, directly you can do it, or otherwise you can do that by differentiation method. Dou s by dou x is equals to 0. By using this one, that means you have to do the partially differentiate with respect to x, then y will be the constant. This one is that y plus this one is that 3, y plus 3 is equals to 0. Now this is that one line. So next one is that dou s by dou y is equals to 0. Partially differentiate with respect to y, then x will be the constant. X plus here is that 3x total constant. This derivative of constant 0. Here is that 3y. Derivative of 3y is that 3 is equals to 0. Right? Now these all represent that these two sides. This one is that x plus 3 is equals to 0. This one is that y plus 3 is equals to 0. Right? The point of intersection of these two is that minus 3 comma minus 3. Because x is equals to minus 3 and y is equals to minus 3. The third side will be 3x plus 4y minus 5 is equals to 0. This is the third side. So clearly that given equations will be form a right angle triangle. In a right angle triangle, orthocenter will be the right angle vertex. Therefore, orthocenter is equals to orthocenter is equals to minus 3 comma minus 3. So this one is that different modal problems related to the orthocenter concept. So first thing is that when orthocenter is given and two sides of a triangle which passes through the origin are given, then how to find the third side. That is the one model depending on the orthocenter. And next one is that how to find the orthocenter when three sides of a triangle are given. When a triangle is that a right angle, then what will be the orthocenter? Right angle vertex. Suppose it is not a right angle triangle, I told you how to find the orthocenter. By using that principles of orthocenter concept, we can find that value. Thank you for watching this video. If you like, please subscribe, like, share and subscribe the channel.